Okay, this is the first video discussing section 2.6 limits involving infinity. There are going to be two types of limits here. Limits where the answers involve infinity and limits where x is approaching infinity or negative infinity. And so dealing with this first problem, obviously it's not one of the ones where x is approaching infinity. We've got x approaches 4. Now, anytime you are approaching a number, you start the limit by doing substitution. You always do substitution first. So doing that, substitution first, I'm going to have 4 over 4 minus 4, 4 over 0. And so what the first part of this lecture is going to be, what do we say when we see that? That the form here, after substitution, is non-zero over 0, and what should we do about that? That we don't know what non-zero 0 as a limit. If it was a functional value, we'd say it was undefined, but as a limit, it's not clear what to do. So non-zero over 0 as a limit will be discussed. So that's what we're going to do. Boy, the handwriting is horrible today. See if I can do a little better handwriting-wise. Will be discussed. And see if we can spell it correctly. Again, if this is a functional value, if this was f of 4, we'd just say undefined and be done with it. But this is a limit. So what I have down here is the graph of x over x minus 4. And we see that we have a vertical asymptote at x equal 4. So x equal 4 is a vertical asymptote. And if we note that the functional value, f of 4, is undefined, and that's why we get, one of the reasons why we get that asymptote. Now, just because a function is undefined does not mean you will have a vertical asymptote, and we'll talk about that more later. What other requirements do you need to have a vertical asymptote? But the first requirement is that your function is undefined. Okay, so if we look at the graph and then look at the limits here as x approaches 4 from the left, and let's do that in green. 4 from the left would be right here. X approaches 4 from the left. And we see that the graph is going nearly straight down. That as we approach 4 from the left, the graph goes nearly straight down. And so we have negative infinity. Because on the left of x equals 4, the graph goes nearly straight down. In pink for the right, in pink, we're looking right there. X approaches 4 from the right. And we see in that case the graph is going nearly straight up, so we're going to say infinity. And basically the same reason, because on the right, of x equal 4, the graph goes nearly straight up. And then finally, the two-sided, all we can say for the two-sided is that the limit does not exist, because left did not equal right. And so the point here is really, this is showing you what your possibilities are going to be when you encounter non-zero over zero as a limit. When you encounter non-zero over zero as a limit, you're either going to get negative infinity, positive infinity, or does not exist. But in all cases, even the infinity and negative infinity, remember those are categories, those are types of non-existence. So when we get non-zero over zero, somehow the limit is not going to exist, but we always want to write the better answer, so you're going to be finding yourself writing negative infinity, infinity, or does not exist, as the case may be. And that is all summarized on the next page, where it says when attempting to evaluate a limit by substitution, and substitution yields the form non-zero over zero, that indicates an infinite limit. The form non-zero over zero indicates an infinite limit. More specifically, limits of the form non-zero over zero equal either infinity or negative infinity or does not exist. Please note that when a limit equals infinity or negative infinity, the limit still does not exist. A limit exists only when it approaches a single fixed number. When a limit approaches infinity or negative infinity, we indicate this because that better describes the situation than writing D and E. Infinity or negative infinity is a type of non-existence. When doing infinite limits, if you are given a two-sided limit, you must consider left and right limits. When doing infinite limits, if you're given a two-sided limit, you must consider left and right limits. Now, a lot of your homework problems, they're going to guide you through, okay, do the left, do the right, now think about the two-sided. I am not necessarily going to do that on a test or quiz. I might just give you a two-sided limit, like this first guy right here, and you've got to realize that if it's an infinite limit, if it's going to be non-zero over zero and it's two-sided, you've got to break it down to left and right. Again, repeating, your homework may guide you through it, but on a test or quiz, you've got to remember this. So doing this problem, we start by substitution. You always start by substitution. So I get 4 times 3 times over 3 minus 3, 12 over 0. And so the point here is I have non-zero over 0, and that immediately tells me that the answer is going to be infinity, or negative infinity, or it does not exist. Now, you don't have to show me the substitution, but you've got to think about it. Just writing down does not exist with no explanation will get you no credit. So it's a two-sided, so must do left, right first. So in no particular order, let's do left. So the limit as x approaches 3 from the left of 4x over 3 minus x. I'm going to substitute first, just like I always do. So that's going to be 4 times 3, 3 minus 3, 12 over 0, which I already had before. But we're going to do a little bit more here. We are substituting from the left. So I'm going to put that little negative 3 there, that little negative, indicating that we're substituting, we're using values less than 3. I don't care about the numerator. Just put the 3 in the numerator. What I care about is what is really going on with this 0. Because it isn't really 0. It's a number really close to 0. And when I have it really close to 0, non-zero over really close to 0, it's going to go to infinity or negative infinity. And what we need to do to decide, what we need to do is decide which it's going to be, is infinity or negative infinity. And so this is going to be negative infinity or infinity, and I need to decide which one. It's not going to be both. Limits always equal one thing. But I need to decide which one. So this negative, as we approach 3 from the left, remember what this means. X approaches 3 from the left means that x is close to 3, but less than 3. Can't see that, can you? So what I've got here is 3 minus less than 3. That's what I got there. 3 minus less than 3. Let's write it out differently. 3 minus less than 3. Well, 3 minus less than 3 is positive. Now, if you can't reason it out, you can't just, reason that out in your brain, you can think this. 3 minus 2.9999999 equals positive. So then this becomes, and this is my own little notation, you're not going to see it anyplace else. This is my own little notation that what I really have is 12 over 0 to the right. That symbol, 0 to the right, means close to 0, but on the right, or that is for positive. When something is to the right of 0, it's positive. So then what I have over here, this is now positive over positive, which makes my answer infinity. It is not going to be negative infinity. The positive over positive has to be infinity. Now, what I'm going to be looking for when I look for these problems, I have to see the non-zero over 0. If you do not give me the non-zero over 0, you haven't justified the conclusion of infinity or negative infinity. So I want to see the non-zero over 0. Then I do want to see where you thought about that denominator, whether it was close to 0 but positive or close to 0 the negative, then the conclusion. But I have to see the non-zero over 0. You do not give me the non-zero over 0, you don't get full credit. You've got to see it. Okay, we'll end this first lecture here, and we'll continue on with this problem in the next recording.